A Roman merchant walks into his storage facility in 100 AD. He's surrounded by massive ceramic vessels, some standing taller than he is, each one capable of holding enough wine to fill 2,700 modern bottles. These aren't just containers. They're technological marvels that helped build an empire. Here is the mind-blowing part. The average resident of ancient Rome drank 250 liters of wine per year. That is almost a bottle per day. The total annual volume of wine consumed in the imperial capital would have literally overflowed the Pantheon. Yet Rome couldn't produce a single drop of this wine within its densely packed city walls. The solution? An ingenious network of ceramic vessels that could store, protect, and transport goods across vast distances while keeping them fresh for months or even years. Today, we re-diving into the fascinating world of dolia and pithoi, the ceramic containers that didn't just store food and wine. They stabilized entire economies and helped Rome conquer the world one preserved meal at a time. To understand why these ceramic vessels were revolutionary, we need to understand the challenge ancient civilizations faced. The preservation problem. Before refrigeration, before plastic, before even glass bottles became common, humanity faced a critical survival challenge. How do you store food and liquid long enough to survive winter, droughts, or long journeys? Early humans tried everything: drying, salting, smoking, and fermenting. But for liquids like wine and olive oil, or goods like grain and fish sauce, none of these methods worked well alone. The Romans inherited a problem that had plagued Mediterranean civilizations for millennia. As their empire expanded, they needed to move massive quantities of goods across vast distances. Wine from Gaul had to reach soldiers in Britain. Olive oil from Spain had to supply households in Rome. Grain from Egypt had to feed millions of mouths. And all of this had to arrive unspoiled. Why ceramic? The Romans didn't invent ceramic storage. The Greeks had their pithoi, and civilizations had been using clay vessels for thousands of years. But the Romans perfected it. They developed the dolium, the ancient world's largest type of ceramic container. These massive vessels could hold up to 2,000 liters, that is over 2,600 modern wine bottles in a single container. But size wasn't the only advantage. The real genius lay in the material itself and how these vessels were used. The science of clay. When clay is fired at high temperatures, above 1,900 degrees Fahrenheit, it undergoes a chemical transformation. The porous structure of the clay becomes semi-permeable. This isn't a bug. It's a feature. Unlike modern sealed containers, these ceramic vessels could breathe ever so slightly. This microporosity allowed minimal oxygen exchange while maintaining remarkably stable internal conditions. The Romans understood something that modern science has only recently confirmed. Temperature stability is everything when it comes to food preservation. Wild temperature fluctuations cause condensation, which promotes bacterial growth and spoilage. Ceramic's thermal mass, its ability to resist temperature changes, created a natural climate control system. Strategic placement. Farmers and merchants didn't just fill these vessels and forget about them. According to research published in scientific journals, the placement and installation of dolia was strategic. They were either buried halfway in the ground or placed under roofs in specific rooms. North-facing rooms stayed cooler in summer, while south-facing rooms captured warmth in winter. The Romans were practicing passive climate control 2,000 years before the term existed. Modern archaeological insights. In 2008, fishermen working near the island of Gorgona in Italy made a remarkable discovery. An ancient globe-shaped 2,000-liter Roman dolium dating to the 1st century AD, remarkably well preserved after 2 millennia underwater. This wasn't just a lucky find, it was a window into Roman engineering. Recent archaeological and scientific research has revealed exactly how these ceramic vessels achieved their remarkable preservation capabilities. The temperature regulation secret. Modern researchers had discovered that large ceramic vessels act as thermal buffers. The thick walls of dolia, often several inches thick, created massive thermal inertia. When external temperatures rose during the day, the ceramic absorbed heat slowly. When night fell and temperatures dropped, the vessel released its stored heat gradually. Clay's thermal conductivity is excellent for releasing fermentation heat, which is why modern winemakers are rediscovering these vessels. During fermentation, wine can generate significant heat. In modern stainless steel tanks, this requires active cooling systems. But clay vessels naturally dissipate this heat without any mechanical intervention, maintaining optimal fermentation temperatures without any additional technology. Humidity control, the hidden advantage. Here's where it gets really interesting. The microporosity of fired ceramic doesn't just allow minimal oxygen exchange, it also regulates humidity. When ambient humidity increased, the ceramic absorbed excess moisture from the air inside the vessel. When conditions became too dry, the ceramic released moisture back. This created a self-regulating microenvironment that kept contents at optimal humidity levels. For wine, this was crucial. Too much humidity and corks would rot. The Romans didn't use corks. They sealed with oil, wax, or clay stoppers. Too little, and the wine would oxidize. The ceramic itself maintained the perfect balance. For olive oil, this humidity regulation prevented rancidity. For grains, it prevented both mold growth and excessive drying that would make the grain brittle and difficult to mill. Chemical stability. Unlike wood, which can impart flavors, or metal, which can react with acidic contents, fired ceramic is chemically inert. Wine stored in dolia didn't pick up woody tannins like it would in oak barrels. Olive oil didn't take on any metallic notes. The contents remained pure, expressing only their own natural characteristics. Recent research from Cambridge University studying Roman vinification confirms that earthenware vessels offered distinct advantages over other storage methods. The clay's neutrality meant that the Romans could taste the true character of their wine, unmasked by container influence. The Roman innovation. The defrutum connection. Romans didn't just store wine, they often added defrutum, a reduced grape must that acted as a natural preservative and sweetener. The ceramic vessels were perfect for this, because the slight oxygen permeability allowed the defrutum to interact with the wine slowly over time, creating complex flavors, while the antimicrobial properties of the concentrated sugars prevented spoilage. Parallel with modern discoveries. The self-healing concrete connection. The article you provided about Roman concrete reveals a fascinating parallel to ceramic storage technology. Just as MIT researchers discovered that Roman concrete had self-healing capabilities through limeclasts, the Romans demonstrated similar forward-thinking in their storage technology. Both innovations share a common thread. The Romans didn't just build things to last, they built them to maintain themselves. The limeclasts in their concrete could repair cracks automatically. Their ceramic vessels could regulate their own internal conditions. These weren't passive containers. They were active preservation systems. Professor Admir Mazik from MIT noted about Roman concrete. If the Romans put so much effort into making an outstanding construction material, following all of the detailed recipes that had been optimized over the course of many centuries, why would they put so little effort into ensuring the production of a well-mixed final product? The same question applies to ceramic storage. The Romans weren't just making big pots. They were engineering sophisticated environmental control systems disguised as simple containers. Economic impact. These ceramic vessels weren't just kitchen equipment. They were the infrastructure that enabled Roman economic dominance. The ability to store and transport massive quantities of wine, oil, and grain meant Romans could trade across the Mediterranean with confidence. A shipment leaving Spain would arrive in Rome months later, with its contents still fresh and valuable. Wine was particularly important. It wasn't just a beverage. It was a crucial part of Roman culture, religion, and even military logistics. Soldiers received wine rations. Religious ceremonies required wine. Social status was partially determined by the quality of wine you could serve. None of this would have been possible without reliable storage. Public health and safety. The preservation capabilities of these vessels had unintended health benefits. Wine and olive oil stored in dolia remained stable for years. This meant fewer instances of spoilage, less food waste, and reduced exposure to potentially dangerous spoiled products. The Romans didn't understand germ theory, but they understood that food from certain containers stayed good longer. The ceramic vessel's ability to maintain stable conditions meant fewer opportunities for harmful bacteria to flourish. Engineering excellence, creating these massive vessels, was no simple task. Potters had to understand clay composition, firing temperatures, vessel geometry, and structural engineering. A dolium that could hold 2,000 liters needed walls thick enough to contain the weight, without being so heavy that it couldn't be moved or would crack during firing. The craftsmanship required was extraordinary. These weren't mass-produced items thrown together on a wheel. Each large dolium was built up gradually, layer by layer, sometimes taking weeks to construct and requiring specialized kilns capable of reaching and maintaining extreme temperatures evenly across a massive ceramic body. Cultural significance. Dolia and pithoi appear throughout Roman art, literature, and law. They were valuable enough to be listed specifically in wills and property inventories. The Latin phrase, ab ovo, usque ad malum, from egg to apple, meaning from beginning to end, references the Roman custom of starting meals with eggs and ending with fruit, all stored in these ceramic vessels. The Greek philosopher Diogenes famously lived in a large pithos, making it a symbol of philosophical minimalism. These vessels weren't just functional objects. They were cultural touchstones that everyone in the ancient Mediterranean world would have recognized and understood. The revival in winemaking. Perhaps the most exciting development is the revival of ceramic vessel winemaking. From Italy to Oregon, winemakers are rediscovering the advantages their Roman predecessors knew 2,000 years ago. Modern clay amphorae and dolia are being handcrafted specifically for wine fermentation and aging. Clay's ability to hold temperature creates a stable environment for wine to slowly ferment without extra temperature control equipment. The neutral material preserves grape variety flavors and aromas, creating wines full of fruitiness and primary characteristics. One Oregon winemaker, Andrew Beckham of Beckham Estate Vineyard, is both a gifted ceramicist and winemaker. He handcrafts traditional amphorae to age his wines, combining ancient technique with modern understanding. The clay's thermal properties, its ability to release fermentation heat naturally, mean winemakers can work without mechanical cooling systems. As one source notes, there is no need for temperature control, especially if the vessel is placed properly, exactly as the Romans did. Sustainable food storage. Beyond wine, researchers are exploring ceramic storage for modern sustainability challenges. Ceramic vessels require no electricity, produce no plastic waste, and can last for generations. In a world concerned about plastic pollution and carbon footprints, the Roman approach offers an elegant, proven alternative. Learning from renowned durability. Just as the MIT study on Roman concrete's self-healing properties could help reduce the environmental impact of cement production, which currently accounts for about 8% of global greenhouse gas emissions, studying Roman ceramic technology offers similar sustainability insights. The Romans created storage systems that required no fossil fuels, no electricity, no chemical preservatives, and no plastic. Their solutions were elegant, effective, and environmentally sound. Modern food science can learn from this approach, especially as we face climate challenges and sustainability concerns. Materials science applications. The microporosity and thermal properties of fired ceramic are being studied for applications beyond food storage. From building materials to industrial containers, the principles the Romans mastered have modern applications in fields they never could have imagined. The next time you pour a glass of wine or drizzle olive oil on your salad, remember that 2,000 years ago, Romans were solving the same preservation challenges you face every time you try to keep food fresh. Their solution wasn't high-tech. It was smart tech. By understanding materials, temperature, humidity, and strategic placement, they created storage systems that could maintain stable conditions for months or years without any external power source, without any moving parts, without any of the technology we consider essential today. The Roman approach reminds us that sometimes the best solutions aren't the most complex. A well-designed ceramic vessel, properly placed and intelligently used, could preserve the wealth of an empire. These vessels did more than store goods. They stored possibilities. They made it possible for a city of 1 million people to thrive, despite producing no food of its own. They made it possible for armies to march across continents with reliable supplies. They made it possible for cultures separated by thousands of miles to share in the same vintage. In an age where we're rethinking sustainability, reducing carbon footprints, and searching for solutions to climate challenges, perhaps we should look back at what the Romans achieved with nothing more than clay, fire, and brilliant engineering. Sometimes the most sophisticated solution is also the simplest. The Romans proved that with the right understanding of materials and environment, you don't need electricity, refrigeration, or plastic to preserve food for the long term. You need good science, good design, and respect for the principles that govern how nature works. Just like their self-healing concrete that lasted 2,000 years, their ceramic vessels remind us that durability, sustainability, and effectiveness don't require complexity. They require intelligence, observation, and the wisdom to work with natural principles rather than against them. That's a lesson worth preserving.